Now, you have been in my lab before. You know how sampling works, and it's that easy. But the only thing that you need to be mindful here is that when you do soil sampling, just like what you did in the preparation of sampling plan, you also need to know why are you doing the sampling in the first place. So most of the sampling can be very easy, but the setup, okay, how many samples you want to collect, where do you want to collect, also need to follow a certain rules. And here in this chapter, we're going to discuss what are the rules or the techniques that we need to consider when doing this sampling work on soil samples. Okay, so the content, we have 7 items. Basically, we're going to learn the techniques and also the planning. So there are certain things that I'm going to inform you on how we select the sampling point and also the sampling size also. I believe Sarus did initially when he explained a little bit about air sampling. A little bit of it also include how to calculate sampling size. It's around the same. Okay. And also a few guidelines on how to handle and store the soil samples. Now this one, the storage and handling, depends on what are you going to analyze. So again, just like what you have been discussing in the air sampling and emission sampling, you're either going to analyze organic or inorganic compounds. So these are happens most likely to be your pollutants also. And these are the things that you also need to consider. And then finally, pre-treatment extraction technique for contaminants in soil. Now, these are the addition because when you talk about extraction, usually that will be done after the sampling work, which means that after you collect the soil sample, you preserve it. Now, preservation comes under pre-treatment. After that, what do? You pass it to the lab assistant inside the lab. So inside the lab, they're going to conduct a few extraction technique. Now, this is extra lah. This is not considered part of the sampling work, but this work also does not count as part of the lab work. I mean, it's in between the sampling and also analysis. So might as well you learn a little bit lah, yeah. Okay, basic principles of soil sampling. We're going to go to it. Okay, now you also need to like first determine why are you doing this sampling, because when you collect the soil samples, there are a lot of reasons why you want to do it. Now, most of the reason is due to monitoring. Of course, environmental sampling, you want to know what is the level of pollution in the medium, either air, soil, or water. Now, in this case, the first objective could be detecting monitoring. Now, in this case, the main objective of monitoring project is to detect whether a contaminant is present or not. Now, in this case, you are dealing with unknown gun. You don't know where it's polluted. So in this detecting monitoring, there are a few strategies that you need to outline because you don't know where it comes from, gun. So you have to map the entire area because you don't know where it comes from. These are one of these. So most likely, due to these objectives, you have to be very smart in selecting your sampling points because you cannot put too many sampling points. The area is too big. You cannot detect like very near sampling point. Most likely during the detecting monitoring, dealing with unknown location of contaminants, you have to space out and you have to arrange the grid, sort of like systematically arrange the sampling point. Okay, moving on to the next one, assessment monitoring. The objective of the plan is to determine the extent of known contamination. Do you see the difference? The second objective is you know there's a contamination and you know where is that. So what do? Then you focus lah. Or you probably don't know the exact area of contamination because usually when contamination happen, it will spread. So the question is how far it spread, how deep it spread. These are the questions you need to answer. Now, do you realize that this question is a lot different than the first objective? But now that you know roughly the specific location, you know where exactly is that. Now, the better question to ask is, how do you know the extent of spreading? Whether it has spread far away, the concentration of the contamination? So usually the sampling point here is much more closer and possibly we possibly going to collect samples in a space in a wide variety of dimension. Either on the surface you spread out or you go deep. How deep is the contamination? Okay, number three, performance monitoring. The objective of the plan is to evaluate the feasibility and required financial burden on the remediation of a pre-investigated area. Now, this one is to evaluate the sampling plan that you have determined much earlier. Now, in this case, we have like determined the area that we want to investigate. Now, in this case, the sampling purpose is to determine, see whether the accuracy and the precision of the result, and also to match back with the investment. You see, the more sampling point you want to determine, the more cost you need to come in. Now, sampling is not free, it costs a lot, which is why previously when you determine the sampling plan, one of the major reasons that limit the sampling size or the sampling point is the cost. And in this case, that is precisely what they are trying to determine. So in this sampling plan, probably they're going to compare what? They're going to compare two different methods. A lot of sampling point or less sampling point. See how far the accuracy and also the precision of the data that you gather. If they don't differ too much, then okay lah. You choose the cheaper method, possibly. And then finally, research monitoring. The monitoring process to be part of a follow-up plan to evaluate the success of remediation effort. Now, in this case, I would say the plan is very similar to number two. The plan will be very similar to number two, in which you have already determined the location of the source of pollution. And then what happened after that, after the second objective is possibly you have some intervention. You put in some work to remediate, to reduce the pollution. And then after that, you have to check, check whether the remediation work that you have put in has the effect on the contamination. So in this case, you will have to recheck again, and most likely this plan, this plan will be very similar to number two. Most likely lah. Of course, the objective is slightly different. The objective is we want to know, okay, the first time you analyze the pollution level, is this high. Then after remediation, you come back. You use the same plan. You collect the same sample and you analyze again. And you want to compare, see if there are reduction and how much. And that is the objective. Although the plan is more or less the same, but the answer, the objective is a little bit different. Okay, parts of monitoring plan. Well, I think this one, I believe you must have heard it from Sir Rusdin. May I have some response? Have you learned this thing under Sir Rusdin? Have you? May I have some response from the students? Have you learned this before? Are you still here? Yeah. When you want to talk, you have to switch on your mic first. Yeah. Have you learned this? Guys, I'm not receiving anything. Are you guys still here? If you don't respond, I assume that you haven't learned and I have to cover everything. Then I skip. If you haven't learned this, then I will cover.
I forgot lah, Doctor.
You're not sure. Okay, so the reason for not responding is because everybody is not sure. Yeah. Okay. Well, why I'm asking you right now is this monitoring plan is exactly what you have prepared in your assignment. Exactly. Because your assignment is also known as a monitoring plan. You go to Sungai Chongkak. and then you want to lay out a plan to analyze the level of pollution due to over tourism possibly, and then you have all this exactly the same. Okay, now a refresher for you, like if you forgot, then I'll come back in. So I'm going to re-explain to you again lah. This might going to take a little bit of time. Okay, so in the monitoring plan, essentially you have 5 parts. You have to go and characterize the site first. Now, this characterization doesn't mean that you have to go to the site and collect sample or whatever. You also can do this site characterization using previous data. Of course, lah, those are part of the job. Because the second part of the job, you still have to go to the site and collect real sample. Yeah. And then second part is you acquire data. Now, data acquisition mostly can be acquired on site where you have like portable tools like your YSI, like your YSI detector. You just put it on soil or water samples, and then you gather the data quickly. But most of the time, this data acquisition was conducted in the lab, where you collect your soil samples, extraction, and then you analyze what are the pollutants at present and how much is the quantity in the sample. And then the third part, most students, at least your level, as I've learned from your response to your lab report, most students forgot about this one, data quality control, in which these are answerable in the error analysis. So in your monitoring plan, you also have to come up with a plan on how to reduce the error. So this is one. How do you reduce the systematic error? Now, systematic error can be so many. It could be due to the error coming from the procedure, the weakness of procedure, or even the weakness of instrument. Some instrument can analyze better, some instrument cannot. So this is where you should comment and how do you overcome the problem. And then once you have determined all these things, only you can certainly say your data either is accurate or not. Because if you're not sure the accuracy of your data, then forget about number 4, interpretation. Because interpretation, you cannot say anything if you're not sure whether your data is correct or not. So how do we know the correctness of your data? You analyze the error. You know exactly what is the uh, standard deviation or maybe the accuracy by comparing with standard. Then only we come to interpretation. Say, for example, you get a certain level, then only you can compare with standard. Malaysian standard in water, Malaysian standard in air, then only you can interpret. So this is number 4, interpretation. And number 5, you put it in reporting. Now, reporting usually comes in 2 ways. Number 1, written report. Number 2, presentation. Now, if you get what I said to you earlier, what is this? This is exactly environmental sampling's all activity from the beginning, from day 1 until today. What we've learned so far is in the classroom only. But these are the things that it covers the entire syllabus of environmental sampling, and this is exactly what you should have done in your sampling plan. The only ironically is you cannot go and gather the data and the real report. So these are the things that we will cover in the monitoring plan. Okay, now to begin with, now the site characterization, I'm going to talk specifically just on the soil sampling itself. So what are the consideration? Now, to begin with, to characterize the soil, to characterize the site, not soil, the site first, the area that you need to investigate. Just like what you did in your sampling plan. You go to Google Map, kan? You go to Google Map and you find where is the location, the area of Sungai Chongkak. Because Sungai Chongkak is not very big, not very small. They have borders. You have to select the borders first. Where is the area? That's just number 1. Because number 2, you find the terrain. In that area, which area is higher, which area is lower? Why it is so important? Because you cannot go and climb that all the time. You have to select the area that of interest. Now, I believe not all of the tourism happens in high ground or areas that are dangerous, like slope with a very high cherut. I don't think you're going to camp there, right? So why bother collect samples over there? Kan? Now, that is just one example. You have to determine the areas that are likely of interest, then you just focus on that area. Kan? Now, apart from the geology that you need to know the pedological characteristic. Pedological is the make of the soil, like what are the minerals? Are those soils peat soils, or are they limestone based, or are they like altered by human activities? These are the things that you should know first before you go in, because when you are doing the sampling, you have some expectation. You already know the soil characteristic, how it should be, and then you can better prepare. Now, for example, let's say if the soil have no soft soil, not like peat soil. Peat soil is very soft, isn't it? Watery and soft. Easily go in, easily comes out. Sampling, no problem. What if the soil is consists of mainly limestone? You cannot get soil samples guys easily by using auger. What are the other methods that you should use? There are actually. Now, all the auger that you use in the soil lab is only one type. There are many types. In fact, there are certain types that are used to gather soil sample with a lot of big rocks. Uh, if you want to know, lah, there are different types of auger. So that is the reason why you need to know first. Hydrogeological characterization. Now, this one is if you want to know the the movement of groundwater. Not all soil sampling requires this knowledge, but if your sampling plan requires you to gather groundwater samples, if that is relevant, yeah, that is also required. Yeah. And then, of course, other relevant information, including historical data about land use, because why? Soil sample is not like, it's not the same. Like, for example, I give you, for example, in 1970s. In 1970s, the soil characterization for sure is very different than today. Because why? It's already 40 years old. In 40 years old, in 40 years, a lot can happen. And that, I mean, that is exactly what it is. You look at KL soil 30 years before is very different than today. A lot has changed. So that's why you need to know what changed it so that you have better expectation on how best you can collect the soil and how best you can plan the sampling plan. Okay, next one, geomorphic and pedological characteristic of the area from the following types of maps. So yeah, you can get these maps, uh, base map, geological map, hydrologic map, overburden map. Now, not all of these maps are available for free. I would say that the geologic map and also the base map, possibly you can agak-agak lah, get it from Google Map. Whereas the hydrologic map, this one is only available from Jabatan Mineral dan Galian. In English, I forgot. In Malay, we call it JMG. Okay? So this is under the Ministry of Environment and Sumber Asli. Overburden map. This one is what is growth on the surface, and this one, together with the soil type, this one is controlled by Jabatan Pertanian Malaysia. So you see, if you want to get this information, you can only get from various sources, and they are not the same. By the way, the sad fact is that if you want to get these two maps, you have to pay. You have to pay them like not much, but several ringgit in order to get this information. Yeah? It's not free information. They're not. Yeah? Okay, next one, class activity. Oh yeah, this is the class activity that you can do, but because of change of delivery. Now, initially I thought I want to deliver it in DK beta. Of course lah, that you can do it inside there. But from here, maybe you can do it later lah. So these are like the link to YouTube where you can see soil sampling strategies and also how best you can use information online to get a survey, okay, a survey on the geology, also the hydrogeology of the map. So these are a few videos that you can watch later. Okay, so far so good. May I have some response, please? I don't want you to fall asleep, because if you do, I can stop for a moment before I continue. Should I continue? It's already half an hour. Should I continue? Yes or no? Yes.
Yes, doctor. Continue.
Yes, doctor.
Okay, good. Can still take it. So I will just continue lah, yeah. 30 plus like to go. Anyway, the next one is selecting a selection or sampling approach. Now, how do you do your sampling? Now, factors that affects the reliability of samples as what you have learned probably in the air sampling, the frequency of sampling. Now, in this case, the more sample size, the bigger the sample size, the more precise, I would say, because once you have many sample size, then you can see actually the fluctuation, and you can use statistics to remove those fluctuation, and in that way you get a more precise data. Okay, so but the problem is, like I said to you, more sampling, more money, and that also you have to consider. Then number two, technical procedures of the sampling collection. The same that I told you earlier on how best you can collect a sample or how best you can detect a pollution in the soil sample. Now, all this there are possibly many methods that you can do this. So which method that you want to choose and why do you choose it? Does it suit your objective? You see, there's no one correct method, and you cannot use one method to apply to all objective. Say, for example, I take CEC. Now, in CEC, you know there are two methods, guys. One that you determine is base saturation. So you leach out and you determine all cation ions and you calculate one by one the CEC kan, lecce kan, yes. Okay. The other one is the sodium acetate method, the one that you did in experiment 9. Both of these are accepted method, you know. These two methods are accepted, but why do I choose CEC by sodium acetate? Because I'm not a farmer, see. I'm not a farmer and I have no interest on what are the nutrients contained in the soil. Well, eventually both methods can answer what I want to know, CEC. But I don't need to go through all the hustle and leach one by one, calculate one by one, the cation ion CEC. All I need to do is I just use sodium acetate method and there I go. I know a CEC because my focus is I just want to know a soil, how much a soil can absorb cation ion. It does its job, right? So another thing, coming back to here, there are many procedures. Choose the one that suits you, and then that leads you to the lowest cost. Okay? So consideration. And then, of course, you have to know your objective. Well, supposedly the objective should be sitting on top, like I would say, because everything starts with objective. If you can answer and you meet the objective, so be it. Use whatever the technical procedures or whatever the sampling frequencies that you wish, as long as they answer the objective. Okay, now, point number 4, technical errors of the operator. Now, this one is people like you, lah, operator. By the way, it's not too far away to say that you guys, if you want to join the workforce, you guys will become this operator, I would say. Because why? You don't have a chemistry degree, kan? So if you have a chemistry degrees like your friends in the chemistry or applied chemistry program, they will be the one who will be able to sit in the air-conditioned lab and receive sample from you. Because why? You don't have a chemistry paper, kan? So you cannot analyze the sample. By the way, what you can do is, since you have a degree in environment sampling, and assuming that you know how to collect sample, you guys will be the operator. But the question is, how good are you? How good are you in doing this? Everybody can collect sample, kan? The question is whether they collect it correctly or not. And therefore, because of this factor, technical errors also comes into play. Because why? A person who is not well trained in analytical chemistry probably will come into this. So this error will definitely cause a lot of types of error, or either systematic error or random error. Both can come in. So these are the consideration, yeah. So that's why. Now this is away from this lecture, lah. That's why in my lecture and also the soil lab, why I push you guys so hard in doing a proper lab report. Because if you can do what is required in my lab report, you will not be too worried about this one. You guys will not be contributing to this technical error if you guys can actually grab and understand my requirement, yeah, in the lab. Okay, moving on, storing. So this one also may be a factor because the soil samples as well as the contaminants, each of them may have a different residence time. They may sit there and stay there forever, but some of them don't. After this, I'll explain. Yeah? And also the handling, how well you should handling this one. Apart from the safety concern, is also due to the cross-contamination. So again, this one, handling, you have to be sure there's no cross-contamination because that also leads to systematic error. Okay, treatment of samples in the course of the collection. Some samples require treatment so that they can stabilize it. Now, the pollutants that you collect from the soil, the moment you collect it, immediately they change. For example, pH. pH change all the time, depending on the microbial activity. Now you say, when you collect a soil samples, obviously soil have microbes inside. So the moment you collect it and you transport it into the lab, there's a certain time it might change. How it change? Because you put it in bag, right? You put it inside the bag, and inside the bag, it seems like there's a lack of oxygen. Therefore, change lah. If there's a lack of oxygen, different than the sampling side, something will change. How does it change? I don't know, but it will change something. Yeah? So that's why treatment there will minimize those changes. Yeah? So usually this treatment will be statistical treatment. Wait. Not statistic. It's not the right way. It's the sampling technique, I would say. Most of the time, it involves the use of chemical. These chemicals will preserve the contaminant so that it stays longer, and by the time it arrives in your lab, you can analyze exactly what you want to know in the soil or from the site, of course. And then, of course, transportation to the lab, the faster, the better, I would say. Yeah. So these are the factors that you need to consider. And then fundamentals of sampling error. Well, this one will be depending on the question will be asked right here is, how big is the sample size do I need? Because the more sampling size that you have, the better of the data sets. But here we cannot afford to run all the samples due to cost reasons. And therefore, you also need to be mindful that the soil samples also is not like water. Water is like they are very mobile. They mix readily. But soil, not so, isn't it? So compared to air and also water sampling, soil probably there's one very inherent error, which is they are not homogeneous. You can only homogenize it manually, but in nature, at the sampling site, they are not homogenized. I ask you, if you look at the soil horizon, how many horizons there? 5, kan? Sometimes less than that, sometimes more than that. And also, when you collect soil samples, how deep is the soil samples that you collect? Only the first that's 30 centimeters, kan? You don't collect 2 meters, betul tak? So that is the indication of soil samples being not homogeneous. How do you solve that problem? We have techniques actually, yeah. But these are the source of error, I would have to say. Because why? Soil, there are varies in sample in particle size, because the one that sits on top, maybe they are finer. The ones that sit at bedrock, they are much more bigger. So they are not the same now. You have to make sure that they homogenize it. Sample mass, of course. Now, soil is known to be heavy. They're dense. Some of them more dense, some of them less dense. And you already know that a soil sample nearer to the surface containing more organic matter, they are lighter. Okay? Now, this is more towards logistic, logistic requirement, and also the degree of heterogeneity are important factors. Okay, sums this up, soil are not homogeneous. So, how many samples you need to take? It depends, depends on your objective and also how much money that you have. So, due to the fact that not all particles are randomly distributed, so you will have to collect your soil samples according to this factor. Okay. You have to determine whether the site of interest, the site that you want to study, have similar particle size or shape or concentration, because obviously they will not. Therefore, what should you do? Now the tips usually is like when you know some idea, like, okay, based on your soil survey that you did before, you roughly know which area have more or less the same soil type. So when you know that, you highlight this area. In this area, you will going to collect soil samples just enough that represent that area only. Now, what about the other area? Of course, they will have different sample characteristic. And then you have to highlight the area differently and collect the soil samples accordingly. So this is what we call judgmental sampling. After this, I'm going to show you what are the different types of sampling. So these are one. Now, apart from that is you also can determine the temporal differences. Temporal means time difference at different certain time. Now, this one examples. Let me see. Yeah. No, figure one. Now, in Malaysia, unfortunately, we have haze. Just a few years ago, only 1 year we don't have haze. Why this is happening? Because at certain time, we have drought. Indonesia also have drought. Then they burn their forest, and then the smoke comes over here, comes back in. You know what happened to our soil? Our soil becomes acidic. Let's not talk about air, about soil. The soil becomes acidic because there are some of the dissolved gases likely to be nitrogen dioxide. When they mix with the rainwater, these are nitric acid. Okay, that is just my hypothesis, because why? Some of the research paper previously, they reported that the soil sometimes becomes acidic and sometimes they become alkaline. What differentiate that is the timing of the haze and also the rainfall pattern. Say, when you look at the rainfall pattern, you have musim tengkujuh kan. So these are the temporal changes. Now, due to this rainfall and seasonal changes, it also affects the characteristic of soil. And therefore, you also need to be mindful whether the soil is comparable. So these are the factors. Sometimes people want to do a long-term study for the entire year, from January to December. They will have to be mindful when exactly the rain changes. And then when the rain pattern change, immediately the soil might change its characteristic. So maybe during that change, you might need to put a little bit more sampling size, sample points, so that you can better expect when exactly the change started and when it ends. Okay. And then of course, segregation. Segregation is very similar to what I said earlier. If you can determine the differences of soil characteristic, and therefore you should segregate and also put your sampling plan differently. Okay, now this variability can be reduced. I would say these are the contributors of random error or fluctuation. Okay, you sometimes you determine, okay, replicate 1 until replicate number 4. Sometimes they are like very uniform, sometimes they are up and down. They are not uniform. So these are the signs of appearance of random error. Now this random error can be reduced by using random sampling or the collection of multiple increments. Now in this case, you will going to determine judgmentally how you will want to take the samples. If there is a very high fluctuation, the solution will definitely be increase the sampling size. You take more sample so that when the fluctuation happen, you average it out. So the more samples you collect, you determine the average, it will cut down the random error. This is one way, this is one way. So how many samples is enough? As you can see right there, these are the general rule. Now, sometimes you may have heard, if you have friends in social science, when you ask them what is the minimum number of samples that you should collect. Now, those from social science, they will have a survey very different than you guys do. They will distribute questionnaire to students, to human subject where they answer. And usually, they will have a minimum number of questionnaire that they need before they can start analyzing. And the number is here, 30. I don't think I need to explain too much when you look at this one. Why 30? Try have a look. You see the width of confidence. It's not very confident if you take very few samples, but the confidence gradually increase if you take more samples. But have a look between 30 and 50. How much is the difference? There's not much of difference. So why do you want to pick 50 samples as compared to 30? 30 is good enough in terms of the confidence level, the accuracy and the precision. The data should be good enough if you take 30. So that's why when you ask anybody from social science, they will say 30 minimum, yeah, minimum, nothing less than that. The more the better, they say, the more the better, but minimum 30. So, which is why in environmental sampling, we also try to pick the same idea. We take 30 samples, but once again, if you can take more, by all means do it, take more. Because the more samples that you get, the more reliable your data. Even though it doesn't differ too much, but that little also can be very meaningful. Of course, with the condition you have a lot of money. So with this assumption, the more samples that you get, it will going to average out the differences, the variables, and reduce the heterogeneity. Okay. By the way, I'm sure you have heard this word before, composite. In water sampling, I'm very sure you've learned Dr. Nick's lesson. There is one sampling method they call composite sampling. So if you forgot what is composite sampling, it is as simple as you take several sampling points, you mix them together, and you make one sample. That is called composite. Why do we do that? Because when you take four replicates, they may be different. So in order to average out all the so-called little difference, you mix them together and take one. This is actually very similar to the quartering method that in soil subject has. Okay, I think once I finish this sampling, then I think I'll stop for a while to give you a 5-minute break. But before that, let's continue some more. Anyway, these are the points that I have repeated. So I think I'll just skip yeah. Now this is exactly the same point that I've explained to you earlier. Okay, to increase the sampling size in order to increase the degree of confidence. And this one is like I told you just now, soil horizon. Why they are different? See, even soil also have 5 horizons. They are not the same. And if you want to take a soil sample on the surface, you also have to consider, is there any objects that are not representing the soil? You have to remove it, like gravel. When you take your soil samples, you remember you have to remove the gravel, you have to remove the organic matter. Then only you sieve to 2 mm. Remember, that is one of the methods that we homogenize the soil. I think I'm going to skip this part because why? If you look carefully, point 1, point 2, point 3, and point number 4, it's exactly what you did before during soil chemistry. And this is why this is one way we collect soil samples, sieve it less than 2 mm, and then we do composite. But of course, there's one more. Once you do this composite in 1 kilogram, there's point number 5. If you can add, there's point number 5. You need to downsize. You need to reduce the sample size by quartering method. Quartering. I believe you learned this before. It's just you have to come back and learn it. Okay? So there's one more point. Now, these are the things that I will going to skip because to sum it up, this is actually trying to say is that if you want to do soil sampling, you can do as many as you want. You can do 30. You can do more, maybe even 300. But the question is it worth it, the cost? And exactly what I said earlier, the cost factor and also the sample size. So here we are again, talking about soil sampling. Now this time, just now we're talking about how many replicates that you need to do. That means how many repetition or sampling points that you need to take. Number's 30. It could be more than that, depending on the condition. Okay, now we are going to talk about how many soil samples you need to collect. Now, you probably don't know that because sometimes they say the more the better, right? Well, it's not like that because, like I said, you have to ask yourself, what exactly you want to know about the soil samples? If you want to know the presence or also the concentration, it depends on how concentrate is that sample. Okay? Now, logically speaking, if the soil sample is not very contaminated, trace, we call it trace amount, you probably need a lot more soil samples to get enough to be detected. Good. So that could be one factor. Vice versa. If you say that the soil is very contaminated, have very high concentration, you don't need 1 kilo, kan? Maybe 1 gram also is enough. So it depends. It depends on the concentration of the pollutants. Now, the other way, let's say if you have a very sensitive instrument, a little bit of contamination you also can detect. That also changed the game, kan? You don't need to take too many samples, take a little bit. But then again, if you want to represent the entire area, a big area, instead of taking a lot of samples, you might want to take many small amount of samples and composite it so that it represent an average of that area. You understand what I mean? That is the reason. You don't need to take too many samples, because if you take too many samples, it incur transportation costs. Apart from incurring some expenditure of your own energy you have to carry, like that, transportation costs, and also you probably don't know about this one, but in some professional lab, they also don't keep their soil samples for too long, and they don't like to keep it because they need to rent a storage. Yeah, companies outside, they don't get the storage for free. Like for example, if you want to store something, if you have a manufacturer, you have a lot of products, you want to store it somewhere, of course you have to be secure, okay? If not, somebody else might going to steal the product away. And also same with your soil samples. If you have a lot of soil samples that you want to analyze, you want them to be very high integrity. That means it's not contaminated, not hampered. People cannot touch it. People cannot cross-contaminate it. So you have to lock it away. So these kind of places requires a lot of investment. You have to rent that place. Of course, lah, we don't normally take, we take just enough. And of course, the last point is because can you imagine that if you dig up the whole soil and you leave Taman Negara or Sungai Chongkak, you think the you think the park ranger will going to let you off? So that's why we take soil samples just for the purpose of our monitoring plan, and not until we damage the environment. So no, we don't take too much. So yeah, based on these factors, now here are the approximate amount. Okay, so a minimum or approximately 200 gram of soil is needed for each characterization. See, 200 gram. I can give you the assumption. If you say 200 gram kan, is 2 genggam. You take your arms, you take 2 soil sample, 2 genggam. Yeah, that's it, 200 gram. Sometimes even less than that. So you don't have to like dig 1 bucket and go home. You just need a little, yeah. And then dry mass of approximately between 5 to 100 gram is needed for contaminant analysis. But do you know between 5 to 100 gram? Why? Because if it's very contaminated, you just need 5. If it's not too contaminated, maybe 100 gram, maybe more than that. But I don't think you can take more than that, because what? Sometimes these soil samples, when you take it back, is not you analyze that 100 gram soil. You need to do something, and it's called extraction. So 100 gram soil, you put some solvent inside, you extract, and then you analyze the extract. You don't analyze the soil. Okay, more soil samples are needed if contaminants are not accumulated in the soil and vice versa. So exactly what I said. 15 liter is required for bioaccumulation tests based on an average of 3 liter sediments per test chamber and 5 replicates. Okay, now this is about bioaccumulation. You know why they need so much sample? Because in terms of bioaccumulation, okay, it could be due to the accumulation by microbes, it could be by insects. And when you learned previously about soil biology, remember how many insects in the soil? Not many, kan? Okay, you might argue with me. Okay, in the soil you have a lot of nematodes, you have a lot of bacteria. Shouldn't be a problem, kan? But let's not forget, they are microorganisms. they have a lot of amount. Once you extract, not enough. That's why you need 15 ml, so that you can collect enough of those biological samples. Then you have enough amount of pollutants so that you can detect it. So this is very similar to the third point lah, yeah. Collect enough samples so that the machine, the instrument, have enough sensitivity to pick up those signals coming from the pollutant. Okay, section of area, sampling points, and perimeter of sampling. So here we're going to go through how we can do the sampling. Hey, likely speaking lah. These are the questions that are asked in final exam. But since there are no final exam, so you're lucky. Okay, forget it. There's only one final exam paper, which is from last semester. When you look at it, these are the answers. Now, how do you choose? Okay, how do you choose this kind of location or sampling points? You choose the first one, the third one, or the second one, or the third one. Now, there's no right or wrong answer because, like I said, at the beginning of this lecture, you should know why are you doing this sampling. The first one, we call it systematic grid sampling. Very uniform, kan? And then, why do we need to make it uniform? Because this is the one that usually we do in order to do the monitoring. Okay? The monitoring, the monitoring sampling plan. You don't know where is the location, okay? So you need to determine. You need to determine all location uniformly. So that's why they are very uniform, because you have no idea where is it. Or you can use another one. Sometimes people use random block pattern. That means still have the grid lines, but the location of the sampling point, instead of uniform and predetermined, it's randomized. So as long as in one box you have 2-3 sampling points, you're okay. And in other words, this one is to like instead of having a very uniform and very structured sampling plan, you possibly can use a random block pattern. Both of which are used for detecting unknown location of pollutants. Okay, the other one, what about traverse type? There can be open traverse or closed traverse type. Now this one, if you look carefully, it seems like they have a trail they follow from from first sampling point until the last sampling point. When do you use this one? Okay. Imagine that you have a sampling site at Highlands. At some point, you're going to move to the foothills. The foothills where you cannot move any further. So what do? You follow along the lines of the foothills, isn't it? So maybe you need to follow the foothills line. Or, say for example, if you want to take soil samples along the river, not the water sample, the soil sample, the sediment just beside the river bank. You cannot walk into the river, isn't it? That is sediment, that's not soil sample. But you want to collect along the river bank. So it could be one. Or, if you look at the closed traverse example, let's say if you want to collect the soil samples within an enclosed area, kawasan berpagar, this could be representing the area where it is fenced up. Also can. Because if you say you want to, most probably the objective of this closed traverse sampling is to detect what is the level of pollutants within the perimeter of the area, kawasan. Why is such that? I don't know. Maybe because the fence itself is a source of pollution, so they just determine that. Or maybe the pollution stopped exactly at the fence area. And it could be. It could be. Yeah. So it depends. Okay? It depends on what you want to do. Okay, more. Now sometimes inside the grid sampling, you can further have the traverse samples. Now this one, it's possibly involving a very large area. Like let's say in a very, very big farmlands. Now, in each of these small boxes, it represents one plot, a plot that may represent a very distinctive, very different soil type, and very different activities. And within inside this plot, for example, you can actually have a traverse plan just to like randomize the sampling point. But then again, you see, in this grid, you have like a random path just to just to represent, okay, just to have the soil samples to represent this area only, okay, this area. And most likely, it depends on what objective. Sometimes people want to know what is the distribution. Distribution means what is the taburan. Of course, when you say about taburan, we got to analyze each of them separately. They are analyzed separately just to see along this line, how does the pollution change? Do they change upwards, downwards, or not? But you see, it also can be composited. That means if you collect all these soil samples along the traverse line, you can mix them together and represent the entire area. So you see, it can work in so many ways. Traverse within the grid, it also can be done. Now, if you look at the picture besides here, also you have traverse line, but the difference is it no longer have the uniform boxes, uniform grids that you have, but it is separated according to some predetermined area. So under what factors that this might apply? Of course, this is applicable to a very flat and uniform field. This probably, you're talking about a terrain which is not uniform. Kawasan bergunung. Yeah, I would say in your sampling plan, you possibly follow this one because in that area, some places are higher, some places are lower, and some places are river. Of course, you don't take soil samples inside the river unless you're taking water sample. So inside the grid position, it can be dead center, every point dead center. Some of them might be following uniformly at one point at the cross section, of this grid, or maybe you can have points that are randomized. Up to you, doesn't matter because anyway, these are the sampling. You don't know yet where is the location, so I mean randomize it. As long as one box you have one point. Okay, now I would say for those who have watched my previous my previous final exam paper, you're going to see something very similar. Yeah, this is a question. Now there are three more types of sampling: judgmental, systematic, and also stratified. Now I won't talk about systematic. That is part of the sampling plan that I have explained earlier. Now what about the judgmental sampling? Now judgmental sampling is when you know exactly the location of the pollution, therefore you will use this one, judgmental sampling. Which means if you know that the site is here, for example, the contamination is right here, you go straight and highlight the area and put several sampling points evenly. Therefore, that is called judgmental. You predetermine the area. Systematic is you don't know. However, stratified is a bit different. Now, stratified here is to divide the area according to their history. It could be due to mineralogy as well. Okay. Now, in this area, I would say that at what condition you use stratified sampling is due to terrain. One of the example is terrain. Yeah? Now, most likely the one at the bottom here, the one that uses uniform grid sampling, this is the one where it is convenient to take soil sample. So evenly. What about the others that are sparsely distributed? See, they are very far away and sparsely distributed. Why? Possibly, these two areas are of non-interest. They're not interested. This area possibly is prejudged that the pollution maybe is not that much and they don't want to determine this area. They just, happens to collect the soil sample. Just in case they want to know. Or there's another reason. These two areas, if it's bercerun with slope, where it is dangerous to collect soil sample, you have two choices. Either you collect sparsely or you don't collect at all. So stratified sampling can be that way. Okay, it can be due to different reasons. Okay? So these are the examples lah. Now this is where the sampling plan can be arranged based on the nutrients. So what you can see right here is the plot of farmlands where each of the plots were already analyzed based on the concentration of nutrient. So this is probably one of the grid sampling. And these are the examples. Once you have all this taken, then you analyze accordingly. Nothing much about. Actually, this is more about method and nothing much about the sampling. Well, next part, I'm going to continue about selection of sampling equipment. Now, this is more technical. I believe no matter how technical it is, it's not very technical. I mean, you already take soil samples, how technical it could be. You don't use your hand, you use auger, and that's it. So this is very quick. Yeah, so stay with me. We're going to be very quick on this one. Okay, tool for sampling, auger. They call it auger, but actually they have different name. They have different types as well. So based on these different type, they also collect that out. Remember just now I told you that some of the augers, they are used to deal with clay, some sand, some even gravel, soils with a lot of gravel. Now the one that use a lot of the one that use soil with a lot of gravel maybe is this one. Not sure, either this one or this one, the first or the second one. Because one of these actually is used to collect clay samples. I'm not sure. I think probably the middle one is a clay samples. I forgot. This one possibly is more open. You see, the tips. Okay, the tips of this auger, they are a bit open. Not that same sharpness, but they are a bit open. Maybe to allow more gravels to go in easily. Okay. Whereas if you look at the last one, the number third one, the third one, it's more close. Now, this one most likely is to stop the content of soil from easily flowing out. I would say this is most likely for collecting sandy soils. You want to close it so that the sand doesn't flow out so easily. Now, these are the accessories. Like usually auger as simple as one pole plus the auger tip, and that's it. But some people, they might extend it. So they might have extended maybe up to maybe 5 meters. 5 meters is what I think is the deepest. Because one pole here equivalent to 1.5 to 2 meters. So if 3 poles, maybe 5 to 6 meters. I haven't heard people go deeper than that. It's quite impossible. So yeah, augers, the length, I'm sure you know, is between 1 to 2 meters. And there is another one. Apart from auger, what the other instrument you also used this before is called a tube. Now this one, very similar to auger, it's also a tube shape. Inside here, they might have some openings so that you can watch and see the changes of horizon along the way. Now usually this equipment is not supposed to be very big. They're not there to collect soil samples in large volume, but rather they are there to collect very small amount of soil samples with very minimal invasion. Okay. Coming back to this one, the invasion is that. Invasion means it disturbs the soil structure. Now with this tip, when they go in, when you twist it, it encompasses the movement of some drilling action. Okay, so they drill slowly, and the circular movement of this tip actually we're going to slowly pick the soil, move upwards, and essentially it minimize the invasion or disturbance on the soil structure. Cannot say there's no disturbance. It is there, but very minimal. This one even less, because why? You see the diameter very small. So what you need to do is just you step on this pedal, and then push it down, pull it up. That's it. You have your soil sample, and it is quite safe to say that this is about 100 and 200 grams. And that's why this is a preferred one. If you want to collect more soil samples, larger volume is the other one you use auger. Otherwise, tube is good enough level. Okay, again, more class activity. Now, this class activity, I think I reserve for you as your own activity. Now, actually, there are more tools to collect soil sample. It could be light power augers, box tight sampler, Helia peat borer, Russian peat borer, and piston sampler. Now, among all these five, I would focus on Russian pit borer. If not mistaken, this Russian pit borer is like a motorized equipment with some drill tips. You just put a machine, use two hands, press it down, and then it just drill down. One of the fastest way to get soil samples, but also the most dangerous one. You need very strong arms to hold those machines. I mean, this machine is like a chainsaw, as big as a chainsaw, but it doesn't saw anything. It just have a drill to drill downwards. So take some time, Google each of these, and then have a look how they operate this one. Of course, these are optional. We don't use this anyway. These are not common soil auger, but by the way, have a look. Okay, now this one possibly is a little bit out of the soil sampling subject, but at times you might want to, you might be needed to determine the underground water table. Yeah. And it's quite safe to say in the future, this might be the main subject. Reason because there are some places simply cannot rain. You simply will not get rain. Like for example, Saudi Arabia, arid countries. And where do they get the water from? Oh, by the way, coming to Mecca, the holy city, okay? Know that they have one very famous commodity, they call it Air Zamzam. Air Zamzam is actually underground water, exactly underneath. Okay. So, I mean, constantly, I mean, the Saudi Arabia government constantly monitor the groundwater level. They also have tips. They also know exactly where is the water table. Otherwise, this Air Zamzam is finished. They constantly monitor. And guess what? This surprising thing is like, it seems like there's a river. There's an underground river flowing from unknown location into Mecca city. And this Air Zamzam never dries because they have a constant flow of river. So that's why Saudi Arabia government is very mindful that they really preserve their monitoring of underground water. But of course, they have to, drill a hole in order to get to this one. Now, the common knowledge, yeah. If you look at the soil horizon, there must be some part where you have water. Now, I won't say it is very similar to the soil horizon where we learn in soil science. Most likely, this water table stops at a level, at a horizon where there is clay. If you still remember, the horizon with many clay is the B horizon. And it's quite safe to say that the first water table, the first part of water table, the shallow ones, resides just above the B horizon. Some soil may not have it, some soil may have it, so it depends, okay? Usually, water cannot flow through clay, so they sit on top. And usually, this water table, what we call it here, phreatic zone. So the zone with many of this underground water, they are actually the horizon with a lot of gravel and a lot of sand. Because this horizon will have space in order for them to accommodate the presence of water. Of course, below this phreatic zone, most likely is clay. Clay cannot flow through, yeah? Okay, now these are the names that you also need to get used to it, okay? Now, what about Weathered zone? Weathered zone, what is the definition? Okay, it's defined as the aerated zone or the unsaturated zone is that column reaching down to the water table. It may be intermittently saturated. Saturated means filled with water. So this zone is called Weathered zone. Most likely it is filled with air. But due to rainfall or the rise of water table, it might going to fill this Weathered zone. Now this surface soil, usually they also consist of vegetation. You may have trees. So if you have trees, usually those roots will going to access into this weathered zone for what? Of course, they need water, isn't it? So most of the roots also stays here. These are the areas where it is filled with a lot of vegetation roots. Now roots don't go into phreatic zone because this is completely soaked with water, and this is the, if you have too much of water, it may cause some root rot. So that is why. So nothing much I can explain to you right here except for the definition. Capillary fringe is the area where they have water due to the action of capillary. So this area is between the unsaturated zone, the zone of soil where there is no water, not enough water, and the area of phreatic zone where this is filled with water. And this line, the line where it is filled with water, is called water table. Structure of soil in regards to groundwater. So next one, classification, soil solution sampling method. Okay, now this subject is between water sampling and also soil sampling. Because all this while when we sample, it's about surface water. But there is one very important sampling that Jabatan Mineral and Galian always do, week in and week out, which is to determine the level of pollution in groundwater. Was not, because that is exactly the thing that people have been doing in Pasir Gudang last time, where there's pollution, people have like gas pollution or whatever. It is rumored that some of this pollution actually doesn't come from the surface, actually comes from the soil itself, because it's so random. Anyway, during that time, most of the people, they have a lot of these techniques in order to collect soil sample, soil solution sample. Last time, as far as I'm concerned, the one that people use, the technique that people use in Pasir Gudang is of a borehole method. That means there are some machine that people have drill a small hole through the soil at a certain depth. From that hole, they collect the groundwater sample and analyze. And surprisingly, in Pasir Gudang, there's only 2 of these such boreholes. And during that time, Mestec is called, during that time, they actually started a very large project with a consultant in order to monitor the environmental pollution. It's real-time monitoring. If that system is fully functioned, you guys don't even need to do environmental sampling at all, because they pass out all these sensors, these measurement monitors, they all set up in every strategic points in the whole Johor, Pasir Gudang included. So unfortunately, it did not take off. Unfortunately, after so much money being invested, it did not take off. And now comes a new government, so no story yet. So you guys have work to do. That's why we need people like you to go out and collect soil samples. Okay, as far as soil solution sampling, there are 2 methods. Either you use a destructive methods or non-destructive methods. And these are the examples. Well, technically speaking, when you want to take soil solution, you need to ask yourself which part of the soil that you want to take soil solution. Because why? The entire soil column, we have water. Groundwater just below or just under the water table, you have plenty of water. Just scoop. Now, what about the one that is nearer on the soil surface, that is unsaturated? Do they have moisture? The answer is yes, they do have moisture, but how do you take it? So based on the different depth that we're talking about here, we have different techniques. And I think most of these techniques are of surface collection. So without further ado, let's look at the non-destructive sampling soil solution. Now in this case, non-destructive I would say more refers to the one that refers to the least disturbance of the soil. As you can see right here, there are zero tension lysimeter or suction tension. What can be seen right here is that now this thing is installed in the soil, underneath the soil. They have sandbag on top, and then they have some 2 inlets to control the flow of moisture. Now, it is said to be like if you have in saturated zone. Saturated zone means that this soil is very wet. Because of that, this moisture is safe to move through into this container through gravity. Yeah, you can see that whatever they collect, the moisture here is gravitational moisture. Very saturated, they have enough moisture, they flow down through gravity, and it can be removed by these things like, because here you increase the pressure, air inlet, where pressure is increased, then there must be some outlet that it can release the pressure. So together with the pressure and moisture, groundwater, they were going to come out from here. So this is a place where they draw the moisture. Or they use suction. Suction means they have a vacuum pump, a pump that sucks all the content here, low pressure, and uh, this porous membrane, we're going to like semi-permeable. It will going to filter out whatever the particles outside, but allows groundwater to flow through. So when this pressure is very low, then the groundwater will going to flow through this porous membrane, and they're going to escape through this tube and into the sample collection chamber. Okay, destructive sampling soil solution can either use centrifuge drainage or saturation extraction method. Now, how exactly this happens is like you need excavation. I believe you need excavation. Let's check. Yeah. Okay, water is added to change the concentration of some anion, and original concentration can be recalculated. So this one, you're going to disturb a bit of the soil. Yeah. Because here they say that in order to collect this soil moisture, they're going to externally add liquid inside. Of course, they're going to change the moisture content and most likely the entire thing inside the soil. So this one will do its job, but usually for environmentalists like us, right, we want to get the result, the data that represent the soil structure as closely as possible. Now, injecting external water into the soil is not really a good idea. It will change everything. So everything you have to recalculate. I mean, that is not the worst part. Because why? The worst part is if you do that, then you no longer preserve the original state of the soil. In other words, you're actually contaminating the soil. So usually destructive sampling soil solution method is not preferred, I would say. It does. It exists, but we don't prefer. Now, I think this one you may haven't seen it before because usually this one is used by agronomists, people in the agriculture. What is this? Doesn't have any description. It doesn't. Okay, now this is actually what we call a rhizome sampler, in which these are actually test tube. It could be test tube, it could be a centrifuge tube. Wait. It could be test tube or it could be a syringe Pichagari, yeah. Because what you attach to this head right here, and then you pull. When you pull the syringe, it creates a vacuum. Now the vacuum inside will going to suck and draw all the all the soil moisture into this tube. So if this is a tube, then initially it is vacuum inside. People just attach to this one and allows the moisture to come in. Usually they use vacuum here. Now what about this tube? This tube, I bought it before. Exactly 3 years ago, I bought a dozen, 12 pieces. It cost me 1,200. That means 1,000, 100 per tube. Why this tube is so special? Because it's not manufactured in Malaysia. It's only manufactured, if not mistaken, in Holland. The tip of, now this tube is just like any other silicone tube. It's a silicone tube, nothing special. What's special about it is the tip of this tube inside the soil. So the tip, you cannot see it because it's inside the soil. It's a white color, semi-permeable membrane. That is why it is so expensive. The moment this membrane breaks, there goes your 100 ringgit. Yeah. This is the common way people use to draw moisture. You can actually find it in a YouTube video. Most likely this one is used by agronomists, apart from climatologists also use this. Okay, what about, okay, now you have learned how to collect moisture sample from the soil. But what about air sample? I don't think I need to describe this so much. Whatever that you use in the air sampling, you have any mechanism to block the soil particles from entering that equipment, that's it. You can do it. Now, coming back to this technique of soil sampling air from the soil, you can just as easy as use a simple method. Okay, how this is done? Air extraction from holes bored with an auger. So you make a hole using the auger. So there's a hole, and of course there's some air inside, isn't it? Then what you need to do is you collect the air samples in an airtight stainless steel or glass container. Now, if you have learned about air sampling, this is very similar to one sampler in the air sampling. What is the name? It is stainless steel. It's vacuum inside. You put it inside the ball, the hole created by auger, release it, sucks the air inside, close it back. As easy as that. Yeah, that is the easiest. I don't think you need advanced method because, frankly speaking, like, how often do you collect air sample for analysis? I don't think so. Usually, in a special circumstances like the one that happened in Pasir Gudang. Pasir Gudang last time when they have this pollution is due to the volatile matter, yeah, the volatile organic compound, VOC. That during that time, nobody realized that it's actually a vapor. No, it's actually a pollutant of a vapor pollutant. So in that case, again, people keep going around trying to find the pollutants. Why they cannot find it? Because it's gas. Gas don't stay there. They move around. And actually, again, they ended up having a vehicle with a real-time monitor, gas monitor, and they go around and pick up the signals. So usually, sampling air in the soil, we don't do too much of the sample. We use real-time monitor. Go to the area, pick up the signal, straight away analyze. We don't sample the air because why? It's not accurate. Why? Why do you need to sample the air since given that you know it's not accurate? The moment you collect the air sample, you bring it back to the lab, it no longer represents the real condition. That's why not many people go and sample air unless you have to. Okay, advanced method. Okay, the advanced method, soil air is sucked through a probe rammed in the soil in a depth of about 1 meter by pumps mounted on the vehicle equipment with a proper analytical facility. Now, this one is exactly what I said to you, the real-time monitor, except that this time they have a probe and they stick it deep inside the soil. I'm not sure what happened in Pasir Gudang because I myself wasn't there. What I know is there's a vehicle with real-time monitor. I have no idea whether they have this probe or not. But in order to determine the air, the volatile contents, the volatile air inside the soil, it's best that you analyze it deep into the soil. That represent the existence of the volatile pollutants in the soil itself, rather than you drill a hole and collect it. Because the moment you drill a hole, it already mixed with the atmosphere. The air already mixed with the atmosphere. Does it represent the air in the soil? No, it doesn't. So the advanced method represent better the air inside the soil. Or you can use a passive sampling. It uses an activated charcoal rod buried in the soil as an in situ absorbent for VOC, and after a few days, charcoal rod is retrieved and analyzed by gas chromatography or another suitable analytical method. So you can say that this passive method is you don't directly collect air sample, but rather you insert a tool or a substance, a material, and that substance will in turn collect those pollutants, those volatile pollutants. Activated carbon is the only thing I can think of. Others, I don't think so. Currently most of the samples, most of the media that people use to have this passive sampling, activated carbon or activated charcoal. So what are the samples to collect sediment? Okay, now we have talked about collecting water or air from soil medium. Now sediment is different. Sediment is of soil material, but this one is underneath water. It could be the sediment under a river, or maybe a sediment under a lake, maybe even undersea sediment. Now we're talking about very deep sediment. It could be very shallow. If it's shallow, we have different ways. But what about deep ones? Okay, we handle it differently. Now, these are the examples of tools that people have used so far to collect soil sediment. Sediment underneath a lake, river, or maybe sea. Now, This one is what we have. We have this one. Okay, it's located in the soil lab even. So this is a sediment sampler. They have a name. Okay, we call it Kajak Brinkhurst coral. It does not require too much of mechanical things. It's quite heavy. It has a very sharp tip, small tip, not very sharp, but small enough. Because what? How this works? You're going to bring this coral into a sampan, for example, or maybe a boat. Next, what you need to do is you tie a rope onto this edge, long rope for your information, very long because you're going very deep, isn't it? And then the next thing is you champa. You throw the entire thing tip down straight into the water, and this one will travel straight into the sediment. Once this travels stop into the sediment, once they stop, then they have a trigger mechanism to close the tip. So once it's closed, they tarik lah, they pull everything in. So what's trapped inside this core barrel is the sediment. That is the cheapest we can get, and this is the cheapest, and this is the one that's available in soil lab. The other three, this one, and this one, A, B, and C, we don't have it. Okay, we don't have it because we did not buy it, and I don't think it's relevant for us to buy it because usually these three are used to gather sample at a very deep water. I'm talking about sea, for example. A and B is very similar. They are like a scoop, they have a trigger mechanism where they can scoop and lock. So usually this one is used by schools that have a marine program. I think maybe UiTM Perlis have this one because there's a marine program there. But what I'm very sure is one of this video actually I borrowed from UMT, University Malaysia Terengganu. Well, these universities specifically have many programs in marine and also environment management. So they actually have a video. One of these video is from them. So maybe you can go and watch it, how this works. Nothing much I can show you because we don't have this equipment. I know this one because I've seen people use this before. So these are the things that people use, yeah, to collect sediment samples. Okay, guidelines for handling and storage of soil sample. Now, it is very similar, I would say. No matter if it's soil sample or water sample, it depends on what contaminants or what compounds that you want to analyze. And from that, we understand some compounds, they might be volatile, some of them might not have a very long stability in air or maybe in certain conditions. And from there, you have to really plan how do you want to handle and store this soil sample. Because what? The main reason why we want to collect soil sample is to analyze its actual content. So changes is what we're trying to prevent. And one of the ways that we can prevent that is have a good preservation and also a storage. And for your information, whatever the soil samples that you collect back, the contaminants there will not stay forever, no matter what time of contaminants. It will change, but you have to know how does it change so that you have a better idea of how to analyze it and report and interpret it. Yeah? So first thing that we need to know is preservation, because why? This is the thing that you should have in mind before you even go to the sampling site. How do you preserve your soil sample? Now, the key is you have to ask yourself, what are you dealing? Are you dealing with organic compounds or are you dealing with heavy metals? Because to preserve these two, it's very different. Yeah? Okay, now, in terms of preservation, the usual way, the usual way is like you did in soil subject, you collect the soil samples, air dried. After air dried, then you sieve. And after sieve, then you put it inside the bag. Okay? And inside the bag, I told you not to seal it. Why? Because the moment you seal it, it becomes low in oxygen and it becomes anaerobic. See, what anaerobic means is it doesn't have air inside, but your soil still have bacteria. So what happens if bacteria survive under anaerobic condition? It changes the soil chemistry. So that is why I asked you not to close it, yeah? So that it represents the actual soil. Now, in order to preserve this soil, preserve actually the state of the chemicals, okay, the state of the analytes, the compounds, the pollutants that you want to analyze, you need to know what kind of compounds that you are dealing with. And fortunately, there is a guideline actually. Depending on what pollutants that you're dealing, there are many guidelines that you can get, and these guidelines depend on the authority lah. Say if it's in US, you have US EPA. In Malaysia, you have DOE. DOE have different guidelines, and their preservation sometimes they might be different. Although generally they are very similar, but they might differ in the quantity and also some difference in handling. Okay, this is the only common chemical preservation method for soil samples is the addition of methanol. Okay, now the third point, by adding methanol and sodium bisulfite, these are actually reducing agent. I would say is to induce reduction so that they reduce the probability of oxidation on the VOC. Now, VOC is something that volatiles easily. They can be easily degraded by bacteria, VOC. It's carbon, hydrocarbon. So bacteria can easily degrade them. And in order to stop that, methanol. Why? Methanol can kill bacteria. One. Number two, sodium bisulfite. Sodium bisulfate. It's a preservative that actually reduces oxidation. See, there are two ways VOC can be destroyed here, either by bacteria or by the oxygen or any oxidants in the soil. Adding these two will help reduce its loss. Okay? So when it is reduced, then the VOC stays there for a longer period of time and they are not underestimated. Okay, now for the containers, wide mouth container are used for soil sample. I have no idea why exactly wide mouth. There is a reason actually. There is a reason why wide mouth containers are used. I just couldn't remember why. But yeah, for VOC only, wide mouth containers are being used. Apart from glass, dark glasses. Now, for preservation of VOC analysis, some of the soil, they may have high range of VOC. Now, if that is the case, then use methanol. Yeah. So these are the guidelines how to use methanol. So these are the range that they deal with. So if it's high level of the VOC is contained, they don't use too much of soil sample, that's fine. And for low level analysis, I mean, if there's not much of VOC, then okay, just use bisulfate. And it's, yeah, it could preserve it. So how low is that? 0.5 microgram per kg. Well, that is if you have prior knowledge, prior information on how much of VOC inside the soil, then you can choose either use bisulfate, sodium bisulfate, or methanol. We don't use both at the same time. So remember, it's either one of these two, depending on how high is the level of VOC. Okay, field preservation is typically done at 1:1 ratio, weight of volume of soil and preservative. And not much, I would say not much of soil sample is being used here. Pre-preserved vials supplied by laboratory are weighed to allow calculation of soil samples. Careful not to add additional label. Now, in this case, if you happen to go to collect soil samples for VOC, you will need to prepare those vials. You need to clean it thoroughly. Ensure there's no VOC inside. Then only you go and sample. Because why? If you ask me, do you have VOC right now in your room, in my room? I would say yes. The question is how much and what type. Why do we need to preserve this one? And why do we need to ensure that they are clean? Because cross-contamination of VOC is so easily happen due to the fact that VOC is volatile. I mean, sometimes when you open the vial, VOC can come in because what VOC is like very mobile due to the flow of wind. They can easily go to your cap and then you close it. And then does that represent your sample? Maybe not. These are like the cross-contamination. Yeah, cross-contamination that might affect the result. Which is why usually for detection of VOC, people usually will avoid using the self-prepared methods. This vial usually is bought. Yeah? And then after you have preserved and collect this sample, how long can you keep this soil? Last point. Holding time for soil sample is 14 days when chilled at 4 degrees. You see, even at 4 degrees, VOC can only last for 2 weeks, not longer than that. Because at 4 degrees, we don't kill the bacteria. Certainly, we don't stop the chemical reaction. What I'm trying to say here is, reaction will still happen, no matter what. If you put it at 4 degrees, most likely bacterial degradation will be reduced. However, the oxygen in the container might still continue with the chemical degradation, the oxidation. And as a result, what happened to your VOC? Slowly they will decrease. They will decrease very slowly. But is that significant? Yeah, they slowly decrease. But if you say you want to analyze a VOC with a very, very small amount, a small changes also might significantly affect the result, isn't it? That's one. Yeah. So you only have 14 days to analyze. After 14 days, what happened to the sample? Throw away. No use at all. Yeah. Okay, so collecting samples for field preservation. So these are the vials that you can see right here. It's quite expensive. So these are the examples of pre-prepared vials that you can buy and you can use it. So these are the instructions. I'm not going to go through that because obviously there are many more other ways to do that. Okay, now what about using sodium bisulfate? So this is how we do it. So using the sampler, you take 5 grams of soil samples and then mix it with the pre-prepared vials containing 20% of sodium bisulfate. So in that vial, you already filled this solution. You add the fill. How you should do it? You take the soil sample, mix it straight away with the vial, close it, go home. No more thing to do. Yeah. Okay. If you have a calcareous soil, then maybe you need to be a bit careful because calcium with sodium bisulfate, they're going to cause the release of gas and they might explode. Not explode, due to the high pressure. Again, the weight ratio is more or less the same with earlier using methanol. 2 vials is used. Well, sometimes people might going to compare these two because when you go to the site, you don't know, right? Most of the time, you don't know how much of VOC you have. So most likely, you're going to have 2 preservatives, either methanol or sodium bisulfate. But you want to be safe, you don't know whether it's high or low, then you do both. 1 sample with methanol, 1 more sample, sodium bisulfate. Okay, collect an addition 3 vials for an MS and MSD. I forgot what is MS and MSD, but these are for other determination, quality check, I would say. Yeah, to determine the accuracy. So you replicate the sample, and then the rest is more or less the same. So once you have determined the preserved samples inside, bring it back to the lab and let the chemist do the job. Because once they're preserved inside, they're going to extract liquid and they analyze from them. Okay, now this one is not new. You must have heard about this word, chain of custody. So, do I need to explain this one? Respond please, do I need to explain this one? I'm pretty sure you have seen and heard this before. Do I need to explain?
No, I think.
Yeah, you already know, kan?
Yeah.
Okay, so chain of custody is like a form you sign and then so that you know who is the handler, the handler of sample and also pass it. Why? Because this one is needed in court. If you want to charge somebody, this one, without it, you cannot charge anybody. So, okay, pre-treatment and extraction technique for contaminants in soil. I think this probably is the last slide that I can show you. I don't want to explain too much because I know you have limited resources last time when you learned analytical chemistry. And these are the methods. Now, unfortunately, whether this is unfortunate. I tell you what, during my time when I was in undergraduate, I learned a lot about analytical chemistry and including these things, all these methods. These are US EPA methods. Now, no matter where you go, these standards will hold up. It's either US EPA or APHA method. And based on this method, they have different extraction techniques because different extraction techniques will address different matrices. Matrices means whether it's a soil sample, water sample, or air sample even. And also what kind of analytes. Now this one usually you can refer as pollutants. Like analytes here is what are the chemicals that you want to analyze. So it could be semi-volatile or non-volatile organic carbon. VOC could be one of them. And it could be polynuclear aromatic hydrocarbon. Because when you look at the entire table, all these pollutants are of organic pollutants. Does people analyze straight away? Maybe, but most likely no, because if you look at the extraction technique, you will need to collect every single organic compound, then only you can safely say that, oh, this is representing the entire content of the organic pollutants inside the soil. Now, in this extraction, people might use liquid. People might just use supercritical liquid. So what is the difference? Liquid and supercritical liquid. Okay, if you don't know how to answer, liquid is liquid. It could be any normal solvent at room temperature. Supercritical fluid are at room temperature is gas. Example, carbon dioxide. But carbon dioxide at high pressure and very low temperature, it becomes a liquid. So the best example, you can say from SFE, supercritical fluid extraction, the last three here, they uses liquid carbon dioxide. Why? You might ask me. Because at a supercritical fluid, it's a liquid, it's non-polar by the way. It mixes very well with this organic pollutant. It mixes very well. They extract them. So they remove them from the soil and they are dissolving all this organic carbon inside the liquid carbon dioxide. Now, how do you purify? How do you purify to get these only, the organic pollutant? You just increase the temperature, let the liquid carbon dioxide becomes gaseous carbon dioxide. What do you left? You are leaving with entire organic pollutant. Why this is preferred? Because as compared to this one, you only get the pollutants. Whereas this one, you still need to remove the solvent. And mind you, if you want to remove the solvent, at the same time, you're probably going to remove the organic pollutants as well, because both of them essentially are the same thing. Solvent, most of the time, is also volatile organic carbon. The only thing that you can minimize the loss is using chromatography, separate them. Okay? Separate the solvent and also the organic carbon. And I think I talked long enough. Probably you might not pay attention here because these are all organic chemistry. Unfortunately, even though you're in environmental technology program, you still need to learn about organic chemistry because, yeah, look at this. They're all organic chemistry. Anyway, these are the table that you can go and find out what is accelerated solvent extraction. I can say to you, if you want to go to the site and collect samples only, then okay, you don't need to learn about this one. But if you want to have a better life, like a chemist sitting in air-conditioned lab and dealing with these samples, then I strongly encourage you to click here and watch how this extraction is conducted. These are the skills that a chemist must know. Or you may not, but if you know, you can improve yourself. So I strongly encourage you to watch that video. And with that, that is all. So before I end this session, just a final note to you. Just like water and also air sampling, whatever that we want to do, storage, collection technique, preservation technique, these are all heavily dependent on what kind of pollutants that you want to analyze. And I think I left out one very important pollutants right here. I haven't talked about heavy metals yet. Why? Because heavy metals is the least of a concern, except for certain heavy metals. Yeah, because usually heavy metals, they stay in the soil, and if there's no apparent change of moisture, there's no leaching, there's no change of pH, it virtually stays forever. Virtually, not exactly. So Usually the most concerning thing about soil sampling is when you're collecting soil samples and you want to analyze something that changes very quickly, such as organic pollutant. So with that, I strongly encourage you to read further. Frankly speaking, my slide here is just enough because I don't want to bore you after this. I strongly encourage you to read further, okay, how to preserve, how to collect based on different pollutants in soil sample.